Hey everybody, welcome to video number 3, Algebra Refresher video number 3 here as we lead into lesson 8.3. One of the other skills that I just wanted to quickly touch base with you about is how to find the distance on the coordinate plane, because that will be one of the measurements that you will need to take when it comes to the triangle diagrams we're going to look at here when we talk about altitudes. So these examples on the back side of your worksheet here is simply one segment at a time, and we want to build this, you guys, off of the Pythagorean theorem. So the distance that we're going to be looking for is simply going to be coming from making the segment into the hypotenuse of our Pythagorean theorem. So essentially we are looking for C, and we are calculating that by taking a squared plus b squared, which, remember, means that we're looking at A here. A is the horizontal leg of the right triangle that we're going to be able to draw off of the segment that we have, and then B here, B is the vertical leg. So let's, on the diagram, go ahead and draw in what those legs would be, and they would go from here on this left end, we'd go all the way across until we're right underneath the other end point, and then we would trace up, and as you know, that's our right triangle. So counting the blocks, it looks like we have a positive 6 change or run on our diagram, and a positive 3 change or rise on our diagram for the letter B. So to calculate our distance is going to be the same as C, remember, which is the same thing as 6 squared plus 3 squared. And doing the arithmetic on that, of course, we're going to do the squared parts first. Keep the radical or the square root around all of it. 6 squared is 36, plus 3 squared is 9, and we know we get the square root of 45. In our last video, we talked about how to simplify that radical. So remember that that is going to break down into the square root of 9, which is our perfect square factor, times the square root of 5, because 9 times 5 gives you 45. And then the square root of 9, the perfect square part right there, that whole thing, the square root disappears because the square root of 9 is 3, and then we have 3 radical 5. So 3 radical 5 is going to be our distance here, okay? Make sure that you guys check that answer. But before you do, I also want you to know one other application that is going to arise when it comes to these altitude diagrams in lesson 8.3. So the last thing I want you guys to look at on this diagram, I'm going to change to purple here. Two things I'd like you to identify, because if this is an altitude problem or if this is a segment within an altitude problem, we're going to need to combine this work that we're doing with finding the distance along with the work that we did with finding the slope and finding the slope of a perpendicular in the last couple refresher videos. So first of all, if I want to find the slope of this particular line, remember that is rise over run, and I've already identified those on my diagram. My rise is positive 3, and my run is positive 6. So the slope in this case, if I were to simplify it, is going to be 1 over 2, or 1/2. And so the last piece that I need to make sure I know is if I wanted to know the slope of a perpendicular, or in the context of our geometry work here in lesson 8.3, the slope of the altitude that I would be looking for, it's going to be the opposite reciprocal, remember. So the opposite, it was a positive 1/2 to begin with, so we're going to get negative whatever it is, and then the reciprocal of 1/2 is going to be 2 over 1, or simply just a slope of -2. Okay, so the two other questions that we're going to be answering, in addition to the instructions that you see of just find the distance, when you see the answer key and you're looking at checking in on number 14 next, make sure you check both the red and the purple, because the purple is going to be asking you, first of all, what's the slope? And the second question that it's going to be identifying in purple ink is going to be what would the slope of the altitude, that's a definition we're going to go over in lesson 8.3 video, be if this segment on the diagram were the base. Okay, so the original slope would be 1/2, and then the slope of the altitude would be -2. So technically we have 3 answers to each one of these questions. Okay? Again, check in on number 14 and we'll go from there. Thanks, guys.